Hey everybody, this is Larry. This is day 23 of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about today's problem. So you may wonder why I'm on this page, and I say this a lot maybe, but I check it once in a while. But you can see that on the upper left, there's a happy lead coding thing, and if you click on it, you get 10 lead coins. Yay, as you can see. Okay, let's actually do the problem though. New problem category, no thanks. Let's see. Today's problem is reorganize string. Apparently I've done it before. Let's see. I hope everyone's having a great week so far. I've been just working out too much. I'm too tired, but we'll see how that goes. I am actually going to bring back, maybe occasionally anyway, do an extra premium problem every day. So because I have to get my money's worth paying for premium, and yeah, just a problem that I haven't done before, especially. So yeah, okay. Today's problem 767. Reorganize string. So given a string S, rearrange the characters of S so that any two adjacent characters are not the same. Return any possible arrangement of S, or return space if not possible. Okay. I mean, the key thing to see is that n is only 500, so you could be greedy. This reminds me of a lot of those problems where n is bigger than 500, or n could be ridiculously big. It doesn't really matter. But in that case, it's a binary. Can you do it or can you not? I guess you can still figure it out. But the idea is that if one character is more than half, then you can't do it just by pigeonhole, right? Of like every other character. Otherwise, if that's not the case, then you can always do it, I believe. Yeah, you just have to kind of find some way to finagle it. And maybe even just take, greedy, take the most common one. And in that case, you could maybe even choose a heap or something like this, but I don't even know if it, Yeah, I don't even know if that you need to do it like that per se, but like a heap seems unnecessarily complex, but maybe that's fine. Yeah, maybe that's fine. I was gonna say there is also some pigeonhole type thing where you can just kind of interleave them, assuming that one character is not more than half the string. Assuming that it is possible, I think you can just you can just kind of go every second one and then loop back and then just go fill them in. By the reason of, I think, pigeonhole, you can prove that this will always give you an answer because it cannot wrap around, because if it wraps around, then you have more than n over 2, which we already know it cannot happen, and we cannot wrap around, then the longest thing you have is going to take the entire string. So even if you don't sort it, it should be fine. Though, I mean, I guess you can always sort the things, but even if you don't, it should be fine because of that reason, because it cannot like loop around to kind of catch up because it doesn't have n over 2. Of course, that assumes n over 2. But yeah, let's create a frequency map first. Easy thing to do in Python. I'm a little lazy, so we can just do something like max of f dot values, right? If this is greater than, okay, so n is equal to length of s. So if this is greater than n over 2, or if it's exactly n over 2, that should be okay. So yeah, if this is over n, then we return empty string. Otherwise, we should be okay. Then we just, yeah, I mean, I don't know. There are a lot of ways you can write this out, I think. Yeah, there are a lot of ways you can write this, I think. One thing I'm trying to think right now is to make sure what I said is true. Actually, I'm thinking about the n is equal to odd case. That's what I'm thinking of right now. And if n is odd, then you can actually have out of over 2, right? Meaning if you have 5 characters, for example, you could actually have 3 characters every other one. So we might have to change this a little bit. Yeah, that's annoying, isn't it? How would I rewrite this? Because yeah, I'm missing that case, because this would return do, but we actually have the answer, right? And actually, in fact, that's example 1 anyway, because you have 3, but you have this thing with 2, so this condition would return incorrectly this thing. How do you do it? I guess you just write +1 over 2 or something like this, right? So so something like this, even though it's a little bit awkward. Yeah, and then you can just move it to the other side. So I think that maybe that's fine then, right? And you can, if you have questions about these, the way that I do it is just play with small numbers, right? So if this is 5, so if n is 5, then this is 6, and we want this 3 to be correct, and this would, this would return. Oh, it would contain you. It would not return this. So I think now this is right. This is a little bit awkward looking. But if if you're here for the derivation, hopefully that makes sense. Otherwise, then yeah. I think in that case, you still don't need to sort if you really want to be precise, and because sorting does make it n log n, which is probably fine. But if you want to keep it linear, technically you can do like a 1 pass max sort to get the max element, and getting the max element and you would have to put the max element on, I guess technically the even indexes, because you would get the max element to kind of put on the even indexes, because the same case, right? The 3 and the 5 or something like that, 3 A's and 5 characters, you want it to be on the even indexes. So that's the only condition in which we're constrained. After that, we can do all things in linear. So yeah. Is it like a max by function or something like this? I never know. In Python, there's so many crazy helpers and functions that but we can just write it anyway. So for key in f of keys, if let's store this, right? So if x is equal to f of k, then the found is found is 0k, and then we break maybe. Right. And then we assert that found is not none. This is probably more complicated than it needs to be, but like I said, we're trying to get a linear time instead of sorting, which would make it n log n. Hopefully this is right, otherwise we're just doing a lot of work for no reason. But part of that is the learning experience. I would also say that I think one comment or question that I get a lot very often in general is how like during a contest, how am I able to prove things so quickly and then move on in code, right? The short answer is I'm really smart. No, just kidding. Just to be clear, no. So the real answer, to be honest, is just a lot of practice. I say this a lot in my comments and stuff like this, and I'm not even talking about. I mean, well, there's some parts about it that's like muscle memory and blah blah blah. But the other thing is that like certain things to be true because you proved it before, right? You played around with it, you're experimenting with it, you spend the time to kind of get the muscle memory, the reps in to kind of be like, okay, well, I proved this before, so I know this is true, so that I don't have to prove it again during the contest, right? Because contest time is way more valuable than what I'm doing now in terms of, in terms of just like trying to optimize for rating anyway. I mean, obviously, at the end of the day, we're all just here having fun, hopefully. But that's basically the short answer, to be honest, right? Is that when I say I've seen it before, okay, there are some times where they just, the problem setter is lazy and it's literally the same problem. But very often, especially if you do code forces and do Q4s and the harder problems, usually it's something that you've seen parts of it before, but not necessarily all of it, right? And then it's about, okay, well, if this problems and this is the other question I get a lot, which is how do I solve Q3, how do I solve Q4, how do I do diff 2Ds or whatever in Codeforce, right? Because that's that's the beginning of having to kind of do multiple components to solve a problem. Maybe each component has an algorithm or something like this, or maybe it's just some observation, right? And the thing is that if you have a problem with 4 components, let's say almost like a video game, if you have 4 components, in order to solve it, and that solving it is binary in the sense that you either get an AC accepted code or you don't, right? You just get the wrong answer, you're a little sad, and you try to figure it out. And you need all 4 components, right? And the thing with timing is that if it takes you X amount of time for each component, but if you know already one component, then you already save like 25% or whatever, right? Obviously, the math is not real numbers or whatever, but you get my point, hopefully. And that's basically the stuff here. And here for this particular problem, and why I brought it up is that, yeah, I mean, we can do a sorting, we can do a heap, we can heapify it, and then, that will be done by now. And, maybe you'll be like, oh, Larry's so smart, you got it in 3 minutes. But right now, I'm just playing around with trying to do it in linear time. That's one. And then 2 is that, to be frank, I hope I don't mislead anyone, in the sense that I think what we talked about, and some of this is from the fact that we've done it before, as I've done it before, or similar problems before. But to be honest, I don't have a strict proof, and what I mean by that is that right now I'm on a discovery quest myself. I'm like, wait, does this actually work? And and whether I get a accepted answer or wrong answer, that's something that I learned for next time, right? So that's basically what I'm trying to do here, and why it's a little bit funky, and sometimes sometimes you have to do a balance between premature optimization or just regular optimization. In this case, it is probably honestly a premature optimization. I would say get it right first, but for me, I feel like the other solution is straightforward enough that I shouldn't need to do it, or like I'm confident about it. So I am. I'm not even. Yeah, it's not even a necessary I mean, it is an optimization, but it's not necessary that I'm going for it because it is an optimization. I'm going for it because I want to learn a little bit about the properties about these problems, and you never know when it comes up. So yeah. Anyway, okay. So getting back to the problem, now that we found the biggest thing, so then now we basically just fill evens with them. So yeah, for yeah, I mean, this should be okay, but I'm just thinking about what's the best way to code this, because we want to make sure that both odds and evens have n over 2 elements roughly plus 1 for the even, possibly, right? So yeah, so otherwise we can just write like evens extend like f of found times found or something like this, right? But this may go over, oh wait, I guess technically speaking, this can never be over evens, because like we said, if it can be over evens, then this would actually already trigger it. So I think this part is fine. And then, yeah, maybe we can do something like, yeah, I mean, I think it's fine. And then now, for the rest of the stuff, I think it doesn't really matter where they are in odds or evens, as long as we're consistent about it. And some stuff will be in both, but obviously as long as if you're in both, not both in the front or both in the back, then you should be fine, just because of the way that it gets up. The way that I will write it is just doing something like maybe something like this, right? So for key and f of keys, if key is equal to found, we continue because we already did it. Otherwise, yeah, if length of evens is less than or times 2 is less than n plus 1. This is basically the same formula as here, as we Hopefully I'm not off by 1. But yeah, we append. Actually, we want to do something like right? So we want to loop this. You could probably be a little bit smarter about it with like max and rounding and stuff like this. But this part I'm like, and this is about knowing yourself. I've been pretty bad about stuff like this. So doing it with a for loop and if statement is slightly inefficient, but we'll be fine. Because at worst it's linear, right? I mean, everything's gonna be linear. But yeah, what am I doing? K. There we go. Else evens. Oh, the other one. Arts.append K. And that really should be it. And then now we can. I think this zip, but zip chops off the last element. That's why I always forget. It's like a zip longer or something, like longest. Zip longest. Okay. Yeah, okay. Yeah, so for, I don't know, AB and zip longest, is that a real thing? Evens, odds. So we have the answer, right? Then we just append append B, or if B is not none for the one case where it is not even, or yeah, for the one case where they don't match up. And then we just kind of combine them together. Let's take a look. This looks good here. This looks good here. I mean, I think technically this already handles it, but yeah, I'm just banging on the keyboard, so we'll just see. It's just some cases. Do we have to minimize it? No. Okay. That's the one thing that I may have made a mistake on, but or just misreading on. Clearly there is some issue here. Oh, the WW. Why is that? Did I misread this? Evens odd. Why would this have an extra W? If it goes W. So this is on even odd, so that means that W is odd. I actually don't know if the last one is even or odd, but I mean, I probably messed up something, but that's a little bit awkward. Huh. Alright, let's see. Did I confuse even and odds? I mean, I think maybe it's possible that this one is off by 1 or something, but I think it's this +1 because yeah, we have to factor in adding the last number for odds. I think there we go. Yeah, because this is the current state, but +1 includes. Okay, if this does not make it go over. Okay, that's why. Silly mistake. Like or yeah, I mean it is definitely silly for whatever reason. So yeah, let's give it a submit. Hopefully, ooh, huh. Okay, so we definitely have an issue here. So A is finding none. Why would we have more odds than even? Dun dun dun. I mean, maybe I still have an off by 1 here, apparently. Yeah. Oh yeah, why is that? That means that this thing is off by something again. Let me look at this real quick. Yeah, we definitely don't want. So okay, so I got lucky on that. This particular one is whatever, because I think in that case it should really just crash no matter what. If I had an odd number, I just wasn't paying attention. Yeah, in this case as well. So basically, adding 1. I mean, maybe I should. I was a little bit lazy. I should have kind of looked at this first. And like if I was not lazy, I would look at this and then, like I said, try to figure out numbers like real numbers, right? In this case, we have 19, so 19, this would be, this would be 20 on the on the right side, and on the right side, if this has 9 elements, then adding this would be, okay, so yeah, I think this has to be this, and I think that may fix it. I'm trying to look at this, and I think that's where I messed up, is that when you invert it, this should be equal, but then I at that time, I thought I was just kind of make sure that I go over it, but then I just got lazy on this part for whatever reason. So yeah, looks okay. And really those are the, and I mean, that's kind of sad, to be honest, because, how did I pass this? Maybe just lucky, I guess. Because it seems like it should fail every case where I have an odd number, so. Yeah, okay, let's give it a submit. All right, there we go. Yeah, I mean, we took the long way and even made a silly mistake, but we did it in linear time and linear space. So yeah, just with thinking and algorithm, or thinking, I guess, because if you want to do with algorithm and data structures, that definitely a heap, or maybe even just sorting is definitely the way to go with the same idea, maybe even. Well, heap is a little bit easier for another reason, because then you can just keep on heaping it. But yeah, that's all I have for this one. Let me know what you think. I'm going to try to do an extra problem, premium problem, so definitely if you're interested, follow me. Yeah, stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.